Welcome back, engineers. In this video, let's talk about the next topic in system design, which is encryption. So it is very important to understand the different concepts inside encryption and security so that we'll be able to discuss them and understand our options, and we'll be able to make better system designs, right? I hope you're ready. Let's get started. So we'll start with the fundamentals. We'll see the difference between encoding, encryption, and hashing. So these are the terms that we hear very often. Let's try to understand each of them in detail, right? So let's start with encoding. So encoding is nothing but transforming one set of characters into another set, at least one type of data into another type. For example, the characters HELLO, when they are mapped against a Unicode set, we get these numbers 104, 101, 108, 108, 111. So every character has a predefined set of numbers along our keyboard, right? And when we do convert these numbers into binary, so this is binary conversion, this is called encoding. So we are converting the human readable alphabets into numbers, and these numbers are converted into binary digits, which is what is used to store the actual characters in our memory, right? So this type of conversion is called encoding. And if we do it in the reverse order from binary to Unicode and then Unicode to the actual characters, we will be able to do the reverse operation as well. So this type of operation is called encoding, right? So some other examples are Morse code. For example, if you look at this chart, every digit and every alphabet has some kind of a pattern, and this pattern can be used to translate any given text into Morse code and the other way back, right? So this is how encoding works. So encoding is reversible and it is not secure because it can be reversed and it can be interpreted by anyone, right? Now let's look at encryption. So encryption follows a different type of mechanism. Let's say I'm sending a message to another friend. Let's say I'm sending a message hi, right? So we must have seen this in apps like WhatsApp where the communication is end-to-end encrypted, right? So what does it mean? It means that the person sending has some kind of a key, and using this key, this particular message is logged or is combined into some gibberish language like this, and this is what encryption looks like. So this hi is converted into some random text like this using some key, and on the other side when it is delivered, the other person also has some other key using which this gibberish can be decrypted and read the message as hi, right? So only the person with the right key can decrypt any message. So that is the whole idea behind encryption. A person sending should be able to lock it using some key, and the person who is able to read it should be able to read it using some other key. And these keys are sometimes shared, sometimes not shared. There are all nuances to it, but the whole idea is nobody in the middle should be able to read it even though they intercept it. So let's say there is a man in the middle who is sniffing on the network traffic. They should not be able to read this data. Even if they're reading it, they should not be able to understand this data. So that's the whole idea behind encryption. So one of the great examples of this was shown in the movie Imitation Game. This was back in the World War II when German messages were being exchanged between the military services about where to plan the next attack or any other secret information, and they were using an encryption technique so that nobody else can intercept. And the British mathematician Alan Turing created a machine called the Enigma, which dealt with these many number of possibilities, 150 to the power of 150 into 10 to the power of 18 possibilities, which were practically impossible to decrypt, right? So they used computational techniques, mathematical techniques, plus some pattern identification like weather reports or some reused phrases during the message exchanges, and they were able to finally crack the algorithm to decrypt the messages, which led to some great impact during the World War II, right? So if you have not seen this movie, I will definitely recommend you to watch this fantastic movie. So the machine looks something like this, really huge, which was calculating many number of combinations, and it was trying to decrypt or intercept the message, right? So that's how encryption works. And the third one is hashing. So to understand hashing, let's take an example of storing a password into a database. So we cannot store the password directly as text into the database because if database is compromised, all the passwords are revealed, right? So in order to avoid that, we use some kind of a hashing mechanism to store some hashed password into the database, so that even if the database is compromised, the actual password is not known. So that's the idea behind hashing. So this is how it works. So let's say this is a user who's keying in some password. Let's say this is the password, my great password, and this password is passed through some hash function. So this hash function converts the great password into some encoded string like this, and this is what we will store in the database. So the idea is to have a one-way translation. This is different from encoding, where it was reversible. This hashing is irreversible. So we will use some kind of a strong algorithm, such as what is used in bcrypt, and we will change this migrate password into something like this. And this thing is not reversible. We cannot go back or use any other algorithm to get back this string, migrate password. And we don't need to. That's the whole idea behind this hashing. So what can we do with this? So this hash function is actually a deterministic function, which means that if an input is given twice, the same output will be given. So the hash function is actually quite reliable in that sense, right? And if you make a slightest change, it will give a dramatic change in the output. For example, if I just say instead of my password, I will say your password, this small change can drastically change this entire string. And that's the beauty of this algorithm used in bcrypt. So the idea is to have a deterministic function like this, which can give the same output every time we give the same input. So whenever we want to verify the authenticity of this user, next time when the user is logging in, let's say, let's say this was the registration process where we actually stored the hash password. Next time when the user is trying to log in, user is going to give this migrate password, and we are going to call upon this hash function to generate this hash again, right? And we will compare the hashes. So hash 1, which is coming from db, and hash 2, which is coming from the hash function, which is used to generate a new hash with the given input, right? If both of them are matched, then we can authenticate the user. We can be sure that this user is authentic. So we don't have to decrypt it, and that's the whole idea behind hashing, right? And what happens if two users have the same password, right? Let's say user 2 is also giving migrate password, and both of them get the same hash password. And when the DB is compromised, we can know that at least 2 or more users are having the same password if we look at the strings, right? So this is a problem. So in order to avoid that, we use something called as a salt. Salt is nothing but a randomly generated unique string per user or per password, let's say. So what this does is, so for this migrate password, it will attach some randomly generated string like this. So combining these two, we then pass it to the hash function to generate the hash password. This way, every user will get a unique identifier for their own hash, and then we will use this to differentiate the passwords between two users. Even though their input is the same, the output in the database will never be the same, right? That's the whole idea behind hashing. So these are the three main concepts that we need to understand when we're talking about data protection, right? Now in this video, let's go deeper into the second piece, which is the encryption, right? This is where we are more interested in. So there are two types of encryption, symmetric and asymmetric. So like I said, encryption deals with keys, and the idea is to have keys in such a way that only the right person with the right key can open the message or read the message, right? So there are two types of encryption like this. First is the symmetric one. So let's say there are two people. One is the spy who's working for some intelligence agency, and this is the headquarters. And the spy wants to send a message to the headquarters, and let's say their communication is symmetric encryption. So with this encryption, what is happening is they both agree upon some cipher system. Let's say when you're sending a message, if you want to write the word letter A, you use this number. If you want to write the letter B, you use this letter, and so on, right? This is some kind of a cipher system which nobody else knows, only these two people knows, and they have this shared key concept, right? So the spy uses this textbook to convert this message attack at midnight into some kind of a cipher message and sends it across, and this is the output. and the headquarters who will also having this book can go through this cipher system again and read it, right? So this kind of cryptography is used for symmetric encryption. But the downfall is, if somebody else gets the key, the whole system is broken. If somebody gets this cipher system, somebody has been able to crack this cipher system, then the whole system is compromised, right? So that's the downfall of symmetric encryption. Now let's talk about asymmetric encryption, which is mainly used in HTTPS, JWT, and so on, right? So idea is, let's say there is a diplomat of some country, and the diplomat wants to share some information with headquarters, and let's say there are some top secret files. So this time they're not going to use a shared key. The headquarters will give some public keys to all the diplomats, let's say, and these diplomats can put these secret files into a box and lock them using that public key. Okay, so let's say there is a lock, and this lock can be locked using public key and can be opened using private key. So let's say this is the situation. There is a lock that can be locked using a public key and then can be opened only with a private key. So the public key that headquarters are shared to all the diplomats, they have used those keys to lock a briefcase and put the files inside it and send it across. And this lock, even though it is visible to the public, it cannot be opened by anybody else, right? Only when it is delivered to the headquarters, headquarters has a private key. Only using this key, this whole briefcase can be opened and the files can be revealed. So this is the idea behind asymmetric encryption, and this is what is used in HTTPS using TLS handshake. Okay, so that's the idea behind asymmetric encryption. Now let's talk about the different encryption levels. So depending on the need or the location of the data, the mechanism used for encryption can be changed. For example, if the data is in transit, for example, there is a client server communication and the data is traveling over the network, that's when we will use the TLS. So this is where we use the private key, public key concept, and we will send the communication across a secure channel. And if the data is at rest, let's say the data sitting in the database, or the data is sitting in some disk, right? Or it is sitting in some blob storage, let's say on an S3 bucket or something, right? So this is data at rest. Data is not moving here. So it is important to also choose when to encrypt this, right? So encryption also is an additional overhead, additional step that needs to be taken care while choosing a system design where encryption is needed, right? So if the data is sensitive or if the data cannot be compromised, then obviously there is a reason to encrypt it, right? And this is applicable to all the data that is at rest, when it's at a DB or a disk or a blob, right? So in the hashing example, we were just encrypting the password and we were leaving the rest of the text as it is, right? So we chose carefully what to encrypt and what not to. But we can also choose to encrypt the entire database, for example. Again, that will add to additional cost, and there is also an overhead for encrypt decrypt for every read and write and so on, right? Similarly for disk and S3 blob, right? We can encrypt our files, encrypt our videos or photos, whatever, and we can be sure. When it comes to disk can also be encrypted. For example, I'm using a time machine backup, and this disk that I'm using is encrypted disk, which means that even though my hard disk, which is taking this backup, is compromised, let's say somebody steals it, they won't be able to restore the data from the hard disk until I provide a password. So I hold the key for this encrypted disk, right? So this is how we can use encryption at rest. And the third level is at an application level. So let's say we are using the concept of JWT tokens. So JWT is nothing but JSON Web Token, which is used to authenticate user sessions, right? So I'm giving a password and I'm trying to log in. And once I'm logged in, I should be able to use the application a number of times. I don't need to be giving password for every route that I'm visiting on a website or every feature that I'm using on the app, right? So for this, there's a concept called JSON Web Token, which carries the session information. Like this token is issued to only those users who are really authenticated themselves, and this token carries some expiry date. So the idea is like this. So the client is giving some credentials and logging in, and the auth server verifies these credentials and provides some kind of a JWT token. So this is just some kind of a string, encoded string that carries some information about the user or the client. And next time whenever this client wants to request any resource, the client will pass along this JWT along with the query, and the resource server will verify and respond, right? This is how we can ensure that nobody needs to provide the passwords multiple times for a session that can be handled using one login, right? That's the idea behind JSON Web Token. So here we are using JWT at an application level, where we are verifying JWT for each query and seeing if it's the right user, and then giving back the requested resource, right? So those are the three levels where encryption stands, right? Now let's talk about the encryption details in terms of files and authorities. So far we kept talking about public keys and private keys and how they are used for encryption and so on. So let's try to understand what these keys are, right? So in the real world, this is how a key would look like, right? So this can open one particular lock, right? But in the digital world, these keys are just files. So these files can be .pem or .key files, and these just carry some kind of let's say hexadecimal or base 64 encoded strings, which are very unique to that particular key, right? And these are unique in nature, so that no two keys are the same, and that's the idea behind having a unique key, something like this. This can only open one type of lock, right? So let's see how this cycle goes. So let's say there are two headquarters A and headquarters B, and they want to exchange information, and they use the public key private key concept. So the headquarter A is having some kind of a public key which has been issued to all headquarters, and they use these top secret files and put them in a briefcase and lock it using this public key. So this is the public lock, and then they send it across to headquarter B, which has a private key and which can open it, right? But how can the headquarter B trust that this is coming from headquarter A? Because this is a public key and many people has this public key, how can we trust from headquarter B's point of view that this is a trusted message? And for that, there are some agencies that provide some authenticity services. So these are some companies that provide digital certificates using which the messages can be trusted. So from private headquarter B's point of view, along with the message, they are looking for this sign. So is this authenticated, or is this a trusted party, which is signed by Temple of Authenticity or some kind of agency which provides these certificates that this guy is who they say they are, right? So along with the top secret files, along with the identifier that this is coming from headquarter A, we add some other certificate so that headquarter B can be safe and can open the provided files and use them, right? So this Temple of Authenticity or these type of agencies are called certificate authorities. So if we just Google certificate authorities list, we will see several different companies that are providing this service. So these are the companies that provide the TLS certificates to companies, and this is what is used when we are actually requesting data. For example, if we go to google.com and click on this little lock here, we can see that connection is secure, and if we go deep into this, we can view the certificate and see that this has been issued by Google Trust Services, whose common name is WE2, and this is the company that has issued the trust certificate or the TLS certificate to this website www.google.com. And if you go to some other website like GitHub, we go to the certificate information, we can see that for github.com there is another issuer called Sectigo Limited. This is another certificate authority. So these are some agencies that provide valid certificates or TLS certificates using which we can be sure, or at least the browsers can be sure, that these are trusted and they say who they are, right? So coming back to the keys, so whenever we are sending something, we send the identity that this is from headquarter A and also some certificate from some trusted third party, right? So that way this third party can ensure that the communication is secure. So let's take this same example and understand this using Google Chrome. Let's say I'm using Google Chrome and I'm requesting a website google.com on, let's say, port 443. Okay, so what Google does is Google needs to identify itself, so it sends a .cer. So .cer is a certificate file which holds the certificate chain, right? Certificate chain is nothing but a series of certificate authorities going up to the root level, and this chain will give Google Chrome a way to verify that google.com is trusted by a third party, right? So let's say Google is sending a certificate that is holding the issuer name as DigiCert. This is one of the certificate authorities, and Google Chrome has a list of authorities like this. So it could be DigiCert, it could be that Certigo, it could be the Google Trust Services, and so on, right? So it checks in the internal list that this DigiCert exists, and it will just verify with that certificate agency, is this legit, and the agency can just confirm that yeah, this one is fine, and that is how Google certificate can be trusted. Now along with the certificate, it will provide a public key. So like we discussed, public key is just a string of hexadecimal or base 64 characters. We can also see this in the browser here. If we scroll down, this is the public key, right? So this piece here is the public key. So using this key, the Chrome browser will create something called as a session key using the public key. So this is the key that is locking the information. And then once this key is created, this session key can only be opened using the private key of Google, right? Because only the right person with the right key can open and decrypt the data, right? And because of this session key, now there is a private line created between Google Chrome and google.com, and using this private line, all the data can now be exchanged and nobody else will be able to read it because it can only be opened using a private key, right? So that's the whole idea, and that is how generally TLS or HTTPS works. So that's all I had for this video, guys. I hope you got some idea about what is encryption, encoding, hashing, what are the different types of encryption, and what are the different types of files, what are certificate authorities, and so on. Do let me know if you have any doubts or if you need any further information about these concepts. I'll be happy to share some information with you. Thank you so much for watching, guys. Do leave a like if you found this helpful. Please subscribe if you haven't done already so that you don't miss out on any future videos. Thank you so much for watching. I will see you in the next one. Cheers.